Yeah, I definitely missed that whole section.
All right. So let's start off with number 1 on the review here. It asks us to identify whether the following sequences are arithmetic, geometric, or neither. Just to remind you, if a sequence is arithmetic, that means that I add to get the next number. If it's geometric, that means I multiply to get the next number. And finding whether or not a sequence is arithmetic or geometric is actually pretty easy. So if we start off with this very first sequence right here, I have 7, -1, -9, -17. If you're pretty sharp, you can tell exactly what's happening here. You can tell you're adding a certain number to the 7 to get to -1, and adding a certain number to get from -1 to 9. But there's an easy way of figuring this out, and I recommend that you use the easy way of figuring it out before you do anything else. So let's test to see if this is an arithmetic sequence or not. So to test if it's an arithmetic sequence, all I have to do is, if I find a common difference, then I know it's arithmetic. So I'm going to try to find a common difference, D, and D is always given by A sub n minus A sub n minus 1. This means that I pick any term and I subtract the term that came right before it. And I want to test to see whether this is an arithmetic or a geometric. So I pick any term. Let's pick the -1. So D is equal to -1 minus 7. So that means that D is equal to -8. So if I test another 2 numbers and I get a D of -8, then I can be pretty sure that it's arithmetic sequence. So let's test another one. D is equal to -9, which is A sub 3, minus -1, which is, so I took the 9 and I said -9 minus the previous term, minus -1, and that should tell me what my D is, what my common difference is. So that's like -9 plus 1, so that means that D is equal to -8. Hey, look, it checks out there and there. So we have the same common difference no matter which numbers I choose. So this sequence right here must be arithmetic. So it's an arithmetic sequence. Now, just